Jai Hind everyone, my name is Ashish Kumar and I am an assistant professor in Department of Computer Science Engineering. Today I am going to discuss the new subject, that is operating system, and the topic of today's session is introduction to operating system and its types of operating system. Okay, let's start the session. So today our agenda to discuss what is an OS, what are its key functions, then evolutions of OS, then what are the popular types of OS. Now firstly we have to understand what is an operating system. So before we start to describe operating system, about the operating system, firstly we need to understand the system. So system contains the hardware as well as the software. So it is the combination of these two terminology, that is the hardware and the software. Now what is software? Software means through which we can interact, or we can say that software is a collection of programs. So software divided into the two categories, one is the application software and the second one is the system software, right? So application software through which we can interact, system software that runs on the system. So operating system is a system software. If I am talking about the definition, so operating system is a system software that acts as an interface between the hardware or as well as the software. So operating system act as a interface in between the this is your OS and this is your hardware and this is the software, right? So it is an interface, or we can say that it is an intermediary or interface between the hardware and software. So as per this line, it is an interface between a user of computer and the computer hardware. Between the user, that means somewhere user interact with the software, or software terminology, that means we can interact with the application software, right? Or it provides a platform to the user or to the application through which we can interact with the system. Without operating system, we cannot directly interact with the system. Suppose if I am talking about the CPU, I am talking about the memory, I am talking about the input output devices, you cannot directly interact with these devices. So if you can interact with these devices, you need the operating system, you need the system software through which we can interact with these resources. So operating system here act as a resource manager. It provides the resources to the different software like applications, right? Okay, so it act as a provide platform. It provide platform for the user. On that platform we can run different applications like MS Word, like Gmail, like Facebook, Instagram, etc, etc. So these are the different applications that runs on the system software. So operating system act as a platform in between the hardware and software. Now, if I'm talking about the next goals. So we have in operating system we have two primary goals. First one is the execute user program and make solving user problem easier to convenient, easy to use. So it is a primary goal of an operating system on which execute user program and make solving user problem easier. Then second one is the convenient. Make the system in a convenient way. As you can see here, if I am talking about the like Windows operating system, it is very convenient because it provides graphical user interface as well as also provide the command user interface, but it provide graphical user interface through which we can interact in a easier way. So the second primary goal of the operating system is the system convenient, and the third and the secondary goal of the operating system is the use the computer hardware in an efficient manner. So it is the responsibility of the operating system that provides the different hardware use of different hardware in a efficient manner. So these are the main primary as well as the secondary goal of an operating system. Now next topic is the structure of computer system. So if I'm talking about the structures of an operating system, we divide different resources in different layers. As you can see here, each layer is isolated and only interact directly with the layer below or above it. So as you can see here, here is the operating system, that is the system software. In the lowermost layer, that is the hardware. So hardware lies on the bottom layer, or it is the innermost layer. Here is the application software, and the topmost layer, here user lies. So at the topmost layer user resides. So user interact with the application software, and these applications are run in the operating system, that is the system software, or operating system is directly interact with the hardware. As you can see here, OS is directly interact with the hardware. So if I'm talking about hardware, so in the hardware mainly we can interact with these resources. For example, like CPU, memory, that is the RAM, and the third one is the input output devices. So this hardware divided into these three components: CPU, memory, and input output system. So operating system directly interact with these resources. So we have a limited resources. So operating system provide as a resource manager, right? So as you can see here, this is the application that runs on the operating system. User can directly interact with these applications. Like user cannot directly interact with the hardware. Through the operating system, we can interact with these hardware: CPU, memory, and input output. Next one is the modes of an operating system. So in a system we have two modes. One is the user mode and the second one is the kernel mode. So operating system lies in between these modes. One is the user mode called as a client, second one is the kernel mode called as a server. So here is the application interface through which different applications are run on this mode, that is the user mode, and here is the kernel mode. kernel mode means only the privilege resources are resides there. User cannot directly interact with the kernel mode. So if the user request comes from the user mode, then through the system call, here is the term, that is the system calls. So through the system call, user request comes from user mode to the kernel mode. So inside the kernel mode, different resources of the systems are lie. For example, like scheduler, like memory manager, like input output device manager, different scheduling approaches are there, system security, file system. So here in the kernel mode, all these resources are reside and these resources are interact with this hardware. So suppose if the user wants CPU access for execution of different processor, so through the system call, user can request to this system, then this system calls comes from user mode to the kernel mode. Inside the kernel mode, on this system call, operating system responds to this system call, then response comes from this to the user mode. So this is the main mode, that is the user mode and the kernel mode. So here is the some statement regarding this mode, that is the user mode is concerned with the actual interface between the user and the system. As you can see here, it controls things, all running applications and accessing files. Then the kernel mode is concerned with everything running in the background, either scheduler, memory management, background application, security. So it controls things like accessing system resources, controlling hardware functions and process program instructions. Then this kernel is a software code that reside in the central core of an operating system. So basically, what does that mean? Operating system divided into the two part. So here is the operating system. So it divided into the two parts. This is your operating system. The core part and operating system called as a kernel, and it is the main core functionality of your system. The outermost layer of an operating system called as an shell, and here is the user. So shell is an interface in between the user or kernel. Kernel is the core part. When the system is start, then the main core part of an operating system is loaded into the RAM. Okay, so as start the system, all operating system are not loaded in a main core functionality of an operating system called as a kernel is loaded into the RAM. So this is all about the kernel. It is also a system software. When operating system boot, kernel is the first part on operating system load into the main memory, that is the RAM. When the system is boot, that is the main functionality of an OS is loaded into this RAM, right? So in a RAM, suppose this is your RAM, here is the kernel. So this portion is privilege mode. Only authorized functionality resides there, and here is the different users applications are runs in the RAM. So user cannot or application cannot directly interact with this kernel. So kernel remains in the main memory for entire duration of computer session. The kernel code is usually loaded into the protected area of memory, as I can discuss already with you. Kernel performs a task like executing processes and handling interrupts in kernel space. Suppose if there is an interrupt occur So all the responsibility of handle that interrupt is the kernel. So kernel perform a task to handle interrupt in the kernel space. Now as you can see here, this is the main functionality of an operating system. So operating system provide different functionality like process management, like memory management, like file management, like input output management, like security, protection and user environment. So as you can see here, operating system provides these different functionality. So let's discuss one by one these functionalities. First one is the process management. So before we start discussion about the process management, firstly we have to understand what is process. So process means it is a program in execution. Let's take an example. Suppose this is your system hardware. All the programs or all the files regarding the programs are resides there. Suppose this is the program, different programs, right? And this is your RAM, right? If the program comes from hardware to the RAM, that is the program is in execution called as a process, right? All the process are resides there. When these process comes from hardware to the RAM, that means this process is in execution. So this is a process. So process is an passive entity, right? Process is an passivity. When the process is in execution, that means somewhere process is an active. So process need certain resources like CPU, memory, files, input output device to accomplish its task. Simultaneously, different execution, multiple process. Here certain execution, termination of process are the more basic functionality of an OS, because in a RAM we deals with multiple process, right? So in a RAM we have a different multiple process. So it is a responsibility of an operating system to manage these processes. Which process is come first, which process is going first onto the CPU. So this is all the responsibility of an operating system to handle the process management, right? So if processes are independent, then the due care needs to be taken to avoid their overlapping in a memory, because we have a limited memory. So it is not possible to contain all processes in a RAM, because RAM has a limited space. So it is the responsibility of an operating system to manage efficiently, in which all the processes are executed one by one and getting the resources. Next one is the memory management. So memory management, here is the how you can handle the RAM, because as I can discuss already, that is a RAM is a limited space, right? Like 2 GB, 4 GB, 8 GB, 16 GB, up to the 16 GB RAM. So we have a limited RAM. So it is also a responsibility of an operating system to manage the memory management. So memory is a large array of words or bytes, each with its own address. It is a repository where data has been shared by the CPU and IO devices. Main memory is a volatile storage device. When the computer may turn off, everything stored in a RAM will be erased automatically. So that's why we says that RAM is a volatile, right? So operating system is responsible for the following activities, that is the keep track of which part of memory are currently being used and by whom. Next, decide which process to load when memory space becomes available, right? So it is also it is the responsibility of an OS to track different parts of memory to decide which processes are loaded into the memory and which processes are erased from the memory. Allocation, deallocation memory spaces are needed as per the processes comes in the RAM. Next one is the file management. So it is the functionality, it is the other secondary functionality of an operating system. So file system provides the conventions for the encoding, storage and management of data on a storage device, like different file management like FAT12, that is floppy disk, FAT16 DOS and older version of Windows, FAT32, that is the older version of Windows, also NTFS, new version of Windows. So with operating system deals with these storage medium as a file system. So it is responsible for file creation and deletion, directory creation and deletion, support primitives for manipulating files and directories, mapping files onto the secondary storage, because we deal with the hard disk in which we reside different files, file backup on stable storage media. So these different activities are deals with the operating system in a file management. Next one is the device management, or we can say the input output device management. So operating system is responsible for manage these devices called as the input or output management. For example, like device controller, device driver, which are the operating system software. Here drivers are the system software. So as you can see here, it is a system software component that interact with the controller. So a special device called as a CPU or called as a interrupt controller handles the task of receiving interrupts, requests and prioritizing them to be forwarded to the processor. Next one is the deadlock can occur when two or more processes have control of different input. Suppose let us take an example. We have a two process P1 and P2, right? And we have a only one resource, and these processes are requesting to this particular resource. So how we can handle, how we can provide this resource to which process? So here as you can see, two processes are requesting for the resources. So maybe there is a deadlock can occur. So it is the responsibility of an operating system to control the resources and ensure that system can never goes into the deadlock. So it is the responsibility of an operating system in a input output management. So here the different activities that deals with device management, like keep tracks of all device connected to a system, decide which process get access to a certain device and for how long, allocate devices in an effective and efficient way, because we have a limited resources. So we provides the devices onto the different users in an effective and efficient way. Different deallocates device when they are no longer required. Next functionality called as the security and protection. So operating system provides the security and protection. As you can maybe you can see in a Windows, like Microsoft Defender. So Microsoft Defender provides the security to protect from the different malwares, different virus, different bugs. So operating system use as a password protection to protect user data and similar other techniques. It also prevent unauthorized access to program and user data by assigning access right permission to the files and directories. So through the, for example, like login and ID and password, when you provide the password to your system, so it prevents unauthorized access. Only authorized access person can open the system through the login ID and through the password. The owner of information stored in a multi-user or network computer system may want to control use of that information. Concurrent processes should not interfere with each other. So this is the basic evolution of an operating system. So first generation of operating system comes in the 1940 to the early 1950. So in 1940s to early 1950s, there was no operating system. All program was done in a machine language or oftenly by wiring up plug boards to control the machine basic function. So in 1940s to the 1950s, there is no operating system. All program was done through the machine language. The next second generation comes in 1955 to 1965. So here first operating system was introduced in the 1950 and it was called as a GMOS. So GMOS created by General Motors for IBM machines, the 701. So this is the machine called as the IBM 701. So it is a single stream batch processing system. Then the third generation comes in the 1965 to 1980, in which introduction of multi-programming. Multi-programs are resides in the RAM and development of mini computer. And the fourth generation 1980 to the present day, that is the development of PC through the birth of Windows and Mac OS, that is called as a Macintosh operating system. So this is all about the history of an operating system. Next one is the types of operating system, in which we deals the different types of operating system called as a batch operating system, multi-programming operating system, time sharing OS, multi-processing OS, distributed operating system, and the network operating system, real-time OS, and the embedded operating system. So these are the different types of operating system. We will cover this topic in the next lectures. So thank you.